Hey, yo, Jesky, you okay?
No, dude, I got an F on the calc quiz.
Hey, it'll be fine.
No, it's not, dude. There's never an 80s club. This is not helping my grade. It's at a C now. It's gonna go to a D after this. There's no 80s club. I miss 80s club. I need it back. That's what's saving my grade, and it's gone. It's never been seen.
Big shout out to that young 80s club. Since then we ain't ever seen a dub. But we still aiming for #1. Integrals and derivatives cancel out like antonyms.
Cancel.
Fundamental theorem calculus. Deriving gives the rate of changing. Product rule when your terms multiply. Chain rule when you got a term inside.
Links.
Product rule when your terms multiply. Chain rule when you got a term inside.
Links.
Quotient rule. Diminish low D high by high D low.
Divide.
Then divide by the square of what's below. To derive fractions, but for integrals.
Yeah.
For integrals, use partial fractions.
Yeah.
Factor denominator, then solve.
Yeah.
Your answer's gonna be a nat log. Deriving shows extrema. Yeah. Relative max and minima.
Min.
Integrating gives you area. Yeah. Like infinitely small Riemann sums. Yeah.
Gonna use Euler's method. Euler. To solve differential equations by using approximations. Step size times differentiation. Delta y. Add that to the previous term value, then the process will repeat anew. Add that to the previous term value, then the process will repeat anew. When you have 2 points A and B, there is a value labeled as C, where the slope between the points is f prime C. This is proven by the MVT. The value graph reaches is the limit, but when it don't exist, it's indeterminate. So use a Hobbes rule to find derivative. Derive the top and bottom, then you calculate. The second fundamental theorem is useful when integrating a sum. Integral. Separate the bounds and integrate each term. I hold this calculus knowledge very firm. Here we have a calculus machine on wheels, because the math can be used to find the acceleration and velocity, and the volume is really important for the wheels.
Integrals can be used for finding the volume of the shape you get when a graph revolves. Move around an axis of revolution. Axes are vertical, horizontal. Graph the base and find the integral. Multiply pi for washer and disk, or by 2 pi for the shell method.
Right minus left.
Add up a sequence, get a series. Go far enough and reach infinity.
Taylor.
But series are not always converging.
Learn.
To find out, you gotta do some testing. The anthem test can only prove divergence. If the terms reach 0, then it's useless. Geometric series use a geometric test. A ratio less than 1 proves convergence. Or use direct comparison. Forget the given series, use a simpler one. Use the root test when you have an exponent. Root converges if the nth root is not over 1. Yeah.
Equation's parametric. When there's a parameter t, it tells you when and where the graph is. X and y have their own t functions. To find the derivative dy dx, first derive the dy equation, then divide by the derivative of x. No need to simplify on the test. Polar graphs use different coordinates. Theta's angle, r is distance. Radius times cosine theta's x. Sine theta divide by radius.
Big shout out to that young 80s club. Since then we ain't ever seen a dub. But we still aiming for #1.